Another tool we could use to help us do integrations, in particular indefinite integrals, are computer algebra systems. Okay, and these computer algebra systems utilize symbolic methods to give us the indefinite form of an integral. Okay, some of the common computer algebra systems include Mathematica, Wolfram Alpha, uh, which is similar to Mathematica. Same company makes these two. MATLAB, or your TI-89 calculator. Okay, those two indefinite integrals. And these could help us even when we are doing integrations by hand. Okay? Now these days, if you're doing a research project and you don't have to prove that you could do integrals by hand, you're probably going to use one of these computer algebra systems to do the integral for you. But even if you are doing an integral by hand, there's nothing wrong with checking your work using these computer algebra systems. So let's take a look at Wolfram Alpha here. Okay, now Wolfram Alpha is pretty good at interpreting what you want it to do. Okay, you could see here that I input this input into Wolfram Alpha. Now I'm basically telling it to integrate this function. I didn't put parentheses around the -1, but it still interpreted it right. I put a comma and then an X to give it the variable of integration. Okay, and it does this integral for me. It's a good idea if you're using Wolfram Alpha to check that it got the correct input. Okay, because sometimes you would need to put in parentheses or be a little more careful. And it'll give us this output. If I change this to say E, it's going to do a different integral altogether. Okay, so here it even got confused because I'm telling it to use the variable E as an integral, and it's used to people putting in X, even though technically it can do something like that, but it got confused because of the natural language. When that happens, if this system gets confused, it's a good idea at that point to use the formal language of Wolfram. Okay, so if you're doing this in Mathematica, you have to use this formal language, and there's no ambiguity. It doesn't have to interpret what you're telling it to do. So if we're looking at this particular integral, which we saw before, okay, there's several ways to do this integration. Okay, we could do a U substitution and then use a table of integrals to arrive at that result. And this is different than the function that I had on Wolfram Alpha. Okay, this is a square root. That other one was to the -1 only. So okay, if we use a table of integrals, we get this. A computer algebra system may give us this result over here. Okay, another one could give us this result, and they're all equivalent. And so you have to be mindful that different computer algebra systems will give you different results, but they're all equivalent. In particular, if we use Wolfram Alpha, here I would just have to change this to a -1/2 instead. And let's see what Wolfram Alpha gives us. So it gives us that result, the second one that we saw. Okay. But sometimes computer algebra systems cannot give you, it'll give you something like this, okay? For a result like sine x squared. That's because the integral of sine x squared cannot be written in definite form. There are no simple functions to write antiderivative for sine x squared, okay? It'll spit out something like this. And S is a Fresnel integral function, okay? Which doesn't sort of help you much because it's basically that integral, right? So There are no other simple functions that we're used to, like cosine, sine, exponentials, logarithms, so it just spits out this result right here for that, okay? And so you can't really get any analytical expression in closed form for the integral of sine x squared. It's not because we just didn't figure it out, and that there is actually something simpler if we try hard enough. There's no simple function that when you take the derivative of it, you get sine x squared, okay? And so if we wanted to integrate this, say, from 0 to 1, we would use numerical methods to do that integral. And now numerical methods are in contrast to the symbolic methods. In numerical methods, you're just trying to compute a definite number, okay? And you have different ways of approximating the integral, right? Ultimately, definite integrals, we interpret them as areas under a curve. And so we could do that by approximating that area with numerical methods. Symbolic methods give us this sort of indefinite integral, the form of the indefinite integral. Okay, it's something that you would do by hand, but you have a computer doing it. Whereas numerical methods, the computer is actually doing the numerical part of it. It's dealing with the numbers, the areas, the specific numbers that you could input into a computer, rather than the sort of human form of doing things where you're actually looking at things and manipulating the symbols. So if we do a numerical integration from 0 to 1 of sine x squared, we would get roughly that from a computer system. From a computer system, or if we even do the numerical methods by hand, which we could take a look at how to do such things.